Hi everyone, welcome back to my 10th video in my series Understanding EMV. In my last video, video 9, we ended the video on this slide where we had discussed her limits and how they pertain to online and offline transaction selection during an EMV transaction. Okay, in this video we will be pushing ahead and hopefully completing this section on EMV parameters. And we will be focusing specifically on the action codes that you personalize on a card. Okay, so let's get straight into it. Okay, so the first set of action codes we need to speak about are issuer action codes. Okay, so issuer action codes are a set of 5-byte action codes which are stored on a chip for use in terminal risk management during a transaction. Okay, so what we're saying here is that even though we personalize the issue action codes in the card itself doesn't use the issue action codes. It passes it off to the terminal, and the terminal uses it for risk management. Okay, and this is a way within the EMV standard for the issuer to have some measure of control in terms of how their card product behaves. You know, when being acquired, perhaps by an acquirer, which is a bank other than the issuing bank, right? So in order to pass these IACs, these issue action codes to the terminal, the chip will inform the terminal of the location of the IACs when it supplies the AFL to the terminal during a transaction. Remember, we spoke about application file locator already. We said that this is a treasure map. X marks the spot. It sends the AFL off to the terminal, telling the terminal that when you do need to access information, here's where you need to come and look at my storage system, and you can retrieve the IAC using a read command. Okay. The issuer sets the IACs during chip card-based personalization. Okay, and these are generally based on broad guidelines from the schemes. Okay, the IACs indicate the action that the issuer wants the terminal to take in each specific circumstance. And we'll go through the circumstances as we talk through the issue action codes. But basically, it drives the decisioning around, you know, whether we should decline the transaction immediately offline, whether we should go online, or whether we should we allow a transaction to approve or decline if it cannot make an online connection. So these are just sample values of what issue action codes will look like when personalized to the card. So what you'll see is we have a set of 3. We have issue action code default, which is tag 9F0D, issue action code denial, which is tag 9F0E, and issue action code online, which is tag 9F05. Okay, and when we write these issue action codes to the card, we write it as a 5-byte hex string, and it'll look like this, right? These are just basic samples that I've thumbs up. Okay. So what we're going to go on to discuss now is to understand the method or how we set up these IACs. Okay, so using the binary format of 1 and 0, we establish that a 1 refers to a yes condition and a 0 refers to a no condition. Okay, so in this way you would read the 3 different IACs. Remember, on the previous slide we said there's a IAC denial, IAC online, and IAC default, right? And the 3 IAC values are sort of read simultaneously, so it makes it easy for human being to understand when they are trying to set up the configuration of these IACs. Okay, so the following table shows the only 3 permutations that may arise. Okay, so if you have a 100, this means decline the transaction, right? You could get a 010, so we're saying don't decline, send the transaction online. But if you can't go online, then normal authorization rules will apply. Okay, and the possibility exists here for either an approval or decline, right? So 100 is a straight off decline offline. A 010 says go online, but if you can't make an online connection, let's look at the other factors in the transaction and see whether we come up with an approval or decline. Excuse me. And the last option is a 011. And what 011 means is don't decline the transaction offline, send it online. However, if an online transaction cannot be made, then we should decline this transaction offline. Okay, so those are the three permutations: 100, 010, and 011. Right, so let's look closer into issue action code. So we're looking at, remember we said it's 5 bytes, so let's look at the first byte. So the kind of criteria, the kind of conditions that are covered by issue action codes as follows. So data authentication was not performed. So what this means is that during a transaction, for whatever reason, maybe the terminal doesn't support it or whatever it is, we could not perform data authentication. This is offline data authentication. This is the process whereby we verify that the card is genuine, and it usually takes the form of either SDA, DDA, or CDA. Okay, so what we're saying here is, in a transaction, okay, should DDA not be performed, okay, what action would you like this transaction to take? And so we've set up the issue action code in this example, right, where we've said don't decline it offline, okay, rather send it online. However, if you cannot make an online connection, then you've got to decline it. Okay, so 011. Okay, next one says SDA failed, and so we're saying, look, if SDA failed, then SDA could fail, CDA, DDA could fail for something unrelated to fraud. It could be something as simple as that the CA public keys on the terminals were somehow corrupted, right? And there is this eternal question: banks, where you have profitability or customer experience versus fraud. So we know you have to find the balance. So in this particular option, it's been set as a 011, which does offer a balance, because we're saying in the event of SDA failure, don't decline the transaction. Rather send it online, because if it comes online, we have an opportunity to do ARQC validation. We can view the PIN if a PIN block is sent up. But if an online connection is not available, okay, then it makes sense. Let's decline the transaction. Okay. IGC data missing, like I said, these are just sample values. This relates to very specific pieces of data, but we've got it set up in this example as a 010. Card appears on a terminal exception file. What this means is the card number on a hot card list on the terminal? Has it been reported stolen, and is this being flagged on all terminals within the country, to be picked up, right? And I mean, here we're saying 100, so we're saying you immediately decline the transaction offline. Obviously, I think it's best practice to rather go 011, because this allows the card to come online, and it gives the issuer an opportunity to send an issuer script down and block that application permanently, so it can never ever be used again, either offline or online. Okay? But now the examples that we're using, so remember, 100, decline transaction. 010, don't decline, send it online. But if you can't go online, let's look at the other factors in the transaction, and maybe we can approve, maybe we can decline. 011 says, look, don't decline it offline, let's send it online. But if we can't make an online connection, then you have to decline it. Okay, so it's important you understand those three permutations. Okay, so the other things issue action codes rules on is things like DDA failed. So the first one talks about CAM or ODA not being performed. Bit 7, bit 4, bit 3, the three different CAM types. These bits covered up the possibility that it was performed, but they failed, right? And what behavior would you like to take? Now, obviously, cards will support either SDA or DDA or CDA. So you would never really have a situation where you've got sort of action codes set up for all three. If the card was a CDA card, you generally have your action codes for CDA, and for the irrelevant stuff like DDA and SDA, you just leave it as all zeros, right? RFU means reserved for future use. So for now, there's no check in these two bits, but as the EMV standard evolves, we could add additional checks going forward. Okay, but the important thing is this: you'll see at the end of byte 1. So we set up the 3 columns: denial, online, default. Okay, and these are the tags, remember, that we write to the card. You'll notice now that in byte 1, we now have binary values here, right? And we can roll this up to get to a hex value. Okay, so 0001 is 1, there we go, and 0100 is 4. So the hex value for byte 1, based on the configuration we've selected here, equals 14. And you apply the same thinking here, right? 1110 translates into hex E, and 1000 translates into hex 8. So the byte 1 value for 9FOF here is E8, and by using the same principle, your byte 1 value is C0. Okay, so we as human beings, what we will do is we will sit with these options, and we will figure out, okay, how is it that we would like our card to behave, under these, in this case, six scenarios catered for under byte 1. Okay, and once we have all of the yeses and the nos, the ones and the zeros defined, we just roll it up and we get a hex value, and so that is how we will write it to the card, right? Let's look at byte 2. Right, so remember, byte 2, same principle. You have a 100, decline, go online, they can't go online, then decline it. Byte 2, let's see what conditions are catered for your chip card and terminal of different application versions, always set to zeros. It's an old legacy check that we don't really use anymore. Expired application, okay, remember we spoke about expiry date on the card in the previous video, and we did say that the expiry date on its own doesn't determine the behavior of whether, if the card is expired, the decision to decline or the transaction or continue the transaction isn't run by that particular tag of application expiry date. Rather, it's run by this issue action code line item here. Okay. And so what the terminal will do is it'll just say transaction date compared to expiry date, and if it's greater than expiry date, it means that the application expired. And then if it is expired, it'll flag, and then in that instant it'll say, okay, so if I've flagged this line item, what behavior should I now take? And we saying as an issue, don't decline the transaction. The guy could be traveling overseas. He's within a few days of returning and picking up his new card. So while he's traveling overseas, let's give him the opportunity to still transact. However, there is a bit of a risk. So if we can't go online, then decline the transaction, right? And similar to expired application, we've got a line item here for application not yet effective. Okay, we've got requested service not allowed for card product, and this will refer to any flags we pick up when we look at the application usage control settings that we spoke about in the last video. Okay, new card, in a transaction, if the ATC equals 0, remember we spoke of ATC, it's a rolling count of every single transaction, the card from the time you start using it till the time it expires. And so if your ATC equals 0, it's flagged as a new card, and then we're saying, what do we do if it's a new card? Would proceed as normal, or would you like to see that very first transaction the customer performs on the online system, right? So you can set it up on your based on your product rules. Just bear in mind, even though I'm saying you will set it up as per your product definition or your product rules, what you find is that MasterCard and Visa have become stricter, so they will recommend certain settings. And if you want to deviate from them, you may actually have to motivate why. What is the reason for this deviation? Okay, so bits 3, 2, and 1 for byte 2 are all RFU. So similar to the first example, we have the set of binary values, and if you roll them up, 0001 is 1, 0000 is 0. So your hex value for this is 10, and the same applies here. You roll it up to 68, and if you roll this up, you'll get, if you convert this to hex, it will roll up to 40. So where we are now, right? So let's track. So remember in byte 1, we had put in C014E8. So now we're saying, cool, we now have the byte 2 hex value, right? So and so we can keep applying the same principle. Okay, so let's look at byte 3. I'm not going to talk through any more of how 100 or 010 or 0011 works. You guys know it for now. Just to discuss what the line items mean. So cardholder verification was not successful. So you've put in an incorrect online PIN, or the next one, unrecognized cardholder verification method. So yeah, it's not one of the CVMs that are listed on the card CVM list, right? What happens if your offline PIN trial limit exceeded? What happens if a PIN is required for a transaction, but the terminal has flagged its PIN pad as not present or not working, right? Or what about a situation where the transaction requires a PIN, and there is a PIN pad in the terminal, but for some reason the customer has not entered the PIN? Okay, what do you do if an online PIN is entered? Again, then you would have to use common sense, follow the guidelines of Mastercard, Visa, Amex standards, etc., and obviously make your selection here in terms of how you would like the card to behave. Okay, but important thing, we roll up the binary values, we get the hex equivalent, and we keep building on the hex values for issue action codes. Byte 4. Okay, in this byte we look at transaction exceeds flow limit. Okay, we're looking at lower consecutive offline limit, upper consecutive. These are your velocity checks, your number of transactions, your alcohol UCOL values. Was a transaction selected randomly for online processing? Merchant forced transaction online. So what sort of rules would we like to put if these conditions are present in the transaction? Okay, we have the hex values after we've selected, and we roll it up again, and then we enter the final byte. Okay, default cheat all used. Don't worry about it too much. Issue authentication is unsuccessful. This refers to after a transaction has gone online and returned. Okay, and the same with bit 6 and bit 5. So generally byte 5 seems to revolve largely around what has happened in the transaction after it's gone online and come back. Okay, script processing always happens after the message returns from the issuer. Issue authentication happens after it's returned from the issuer. So you would set your rules here. You would roll it up to its hex equivalence, and what you would end up with is, now at the end of working through byte 5, you now have 3 hex values that you can write to the card. Okay. So let's look at our example. We had issue action code default, denial online. We've got a 5-byte value. Okay, so we take this and we will put, obviously 9F OD, 9F OE, 9F F with the length indicator of 5, and then we put the value. So remember, so it'll be tag, length, and value, and this will go into the card. Okay. Yeah, don't stress if the hex to binary conversion seems a bit complicated. You can go online. There's tons of online converters that will do this for you on the internet. But yeah, later on, I do have a section in this training that will sort of discuss the conversions between hex to binary to decimal, etc. And yeah, hopefully it will simplify it for you as well, right? But like I said, if you can find lots of converters online. Okay, let's move away from issue action codes and let's now talk about something called card issue action codes. Okay, card issue action codes are a set of 3-byte action codes. So issue action codes are 5 bytes, card issue action codes 3 bytes. Okay, and these are stored on the chip. Different once again from issue action codes. So card issue action codes are used by the card and they are never shared with the terminal. Right? If you compare it to issue action codes, those are, even though they're stored on the card, they're never used by the card. They are passed on to the terminal. Okay, so for this 3-byte value, just remember card issue action code, personalized to card, used by the card, never shared with the terminal. Okay. card issue action codes are specific to MasterCard, right? So you won't find this on Visa, on Diners cards. They have other, well, they have action codes as well, but they call it something else. And I think after card issue action codes, we will be discussing. We should be discussing uh, the Visa action codes and what that looks like. Okay. Right, so the issuer sets the card issue action codes during chip card personalization, obviously based on guidelines on the schemes. These CIACs, as we refer to them, indicate the action that the issuer wants the terminal to take in each specific circumstance. So decline, and when I say terminal, what we're saying is, remember, this is the this is used by the card itself, but obviously because the card has the final say in an EMV transaction, the card decision once made, the terminal will have to abide by it. Okay. So similarly, we have examples. So it's very similar in methodology to issue action codes. We would write it to the card like this. The tags are C3 for denial, C4 for default, and C5 for online. And you would write it as a 3-byte hex value that looks something like this, right? So let's have a look at byte 1. Right? So what are the things that the card uses for its risk management when it uses card issue action codes? So it looks at if the last online transaction not completed, what action would you like to take in this transaction, this new transaction? If the terminal has indicated that it's unable to go online, what action would you like to take? If offline print verification was not performed, what action would you like to take? If offline print verification was performed but it failed, okay. If your print try limit is exceeded, if it's an international transaction, is a domestic transaction, the terminal erroneously considers offline print okay, right? So in the same principle, it's a 100 for decline offline, 010. Now let's go online, but if we can't go online, no biggie. We'll have a look again and see either we approve it or we decline it. And of course, the 011 means let's try to go online. Now it is a biggie because if we can't go online, we're going to decline this transaction. Okay. So same principle as issue action codes. We roll it up into its hex equivalent and we write it to the card. So we've got byte 1 written already. Okay, let's look at byte 2. Byte 2 talks about lower consecutive counted, so velocity limits, lower and upper, cumulative transaction amount limits, lower and upper. There's a flag on the card that says go online on that transaction. So you have to set, what would you like to do? Try to go online, and if you can't, then decline the transaction. If issue authentication failed in the last transaction, if a script was received, if a script failed in the last transaction, how would you like the card to behave? Right? Roll it up to the hex value, and we've now populated byte 2. Okay, byte 3, you'll see that the first 2 are now counted 2 and accumulated 2. So these are velocity checks. These are transaction amount accumulators. But you generally under a MasterCard specification, you will split it. So you use, for example, counter 1 for your contact interface and counter 2 for your contactless interface, right? MTA limit, maximum transaction amount limit exceeded. It's a limit that you can set on the card. It's unique to the M-Chip Advanced specification, and if that limit is exceeded, you can decide what action must be taken here. There's also a limit indicating number of days offline limit exceeded. So you can say if we haven't seen the card in I don't know, 7 days, 14 days, then the next time it comes online, you could insist that it comes online just to verify and make sure everything's okay, that the card hasn't been stolen, that something has happened to the card or what have you. Okay, there's additional check tables, etc., etc. Once you have the binary values in place, the yeses and the nos, roll them up to hex, and now you've got complete 3-byte values for each of the 3 tags. All right. So in our example, we said, okay, we worked through the binary, we wrote it up to hex, and now we've got full values for these tags, and we will write this to the card, right? Exactly as it is in its hex state that we can see here. Okay, so as I've been saying, basically the same principle as issue action codes. Remember, issue action codes written to the card but passed to terminal in a transaction for terminal to use. Card issue action codes written to the card used by the card itself. Okay, that takes us to the end of card issue action codes, and in the next slide we are going to discuss the Visa equivalent, of card issue action code, which is known as application default action, or ADA for short. It's tag 9F52. So application default action is a 6-byte action code that's stored on the chip for use in risk management during a transaction. It is specific to Visa, right? So remember, card issue action. So issue action code exists across all the schemes. Okay, card issue action code specific to MasterCard. ADA specific to Visa. Okay. The format is different from the card issue action code format, as we do not make use of 3 sets of codes to define denial on a default. So in this, for Visa ADA, we don't use the system of 100, 010, and 011, right? Instead, ADA looks like this, right? So you have byte 1, and let's look at some of the bits. It says, if issue authentication failure, transmit next transaction. So you can say that if a transaction it declines because of issue authentication failure, you can set a flag. This will cause a flag to be set on the card, so that the next time the card is used, it will be forced to go online. Online mandatory, right? If issue authentication performed and failed, decline transaction. If issue authentication is mandatory and no ARPC received, decline transaction. Okay. If transaction is declined offline, advice. If printer limit exceeds on current transaction and transactions declined, credit. Right. So basically, I'm not going to read through everything, but basically, we are still working with ones and zeros. Okay, so let's assume for byte 1 we are busy building a product, and we're saying we would like this to be set on, bits 8 to be set on, bit 7, bit 6, and bit 2 to be set on, and everything else must be set off, right? So we're saying a yes is a 1 and a no is a 0, as we've discussed previously. So what this means is you'll have 1, 1, 1, 0, 0, 0, 1, 0. So if you write it down, it looks like that. And if you convert that to hex, what you end up with is a value of E2. Okay. Let's look at byte 2. Okay. So byte 2's got things like, you can see a lot of it's around pins, so if pin try limit exceeded on current transaction block application. So what you're actually saying is, if you block your pin try limit, you can set this to block your application. So the card is not usable unless the customer goes into a branch and gets the application, unblocked or the card replaced, or whatever process the issuer uses, right? And I'm not going to go through all of these. You're welcome to look at the specification. You're welcome to pause the video here and just look at all of the options that are available here. But the principle is the same. 1 is a yes, 0 is a no. Okay, you choose the ones that you want a yes for, so those become ones, and everything else becomes a 0. So you get 0, 0, 1, 1, 1, 0, 0, 0. Convert that to hex, and you end up with a value of 38. Okay, byte 3, same process. I'm not going to go through it again once again in detail. I think you understand. If you do want to look at it, the specifications are available from Visa. Alternately, just pause the screen and you can sort of have a look at what the options are. But the principle is, select the bit set you want to set on, set those to 1, everything else is a 0. That gives you an 8-character string of binary values, which you then convert into a 1-byte value, and in this case it's 20. Okay. Same with byte 4. Okay, so slightly different here because you can see you've got bit 8, but you've got bit 7 and 6 combined. So if you read this, so what you're saying is default double count reset velocity checking count is 0, right? So the way you would read this is 0, and then you read this as we chose this option, so this 1 0, right? And then everything else is zeros, right? So it's 0, this 1 0, this 10, or this 1 0 is 0. Okay, and then that just rolls up into a hex value, which is 440. Okay, again, more pin specific stuff in byte 5, offline pin verification not performed or not successful, send transaction online, etc., etc., etc. Select, write the binary value. I just have got byte 5 and 6 in here because generally byte 6 tends to be all 0. CD-CVM supported. Yeah, that's more on the contactless side. So I'm not going to get into it here in this contact training. But at the end of the day, we have an ADA value tag 9F52 of 6 hex bytes, right? So in the example which has been through, here is the hex value E23820400800. We write it to the card. Similar to the way we discussed before, it's written as a single hex value on the tag 9F52. Remember, ADA is the Visa equivalent of the MasterCard CIAC. So the ADA is used by the card itself. Okay. I think we're going to stop here. I see this video is quite a bit shorter than the previous two. Thankfully, my throat is quite sore from all talking. But yeah, so this brings us to the end of the EMV parameters section. Remember, just to recap, that the items or the content that we've discussed under this section, as I said, not comprehensive. It focuses mainly around MasterCard and Visa, and it doesn't have everything. There's lots of other EMV tags, that are also personalized to a card that I haven't discussed, and you're welcome to do more reading and internet searching and what have you. Read through the EMV code specifications, read through the MasterCard Visa specifications to better understand those. Okay. The other thing I need to point out, I said it before, but I'm just going to repeat myself. I know it's quite a lot to take in, especially this section. Don't stress if you can't remember everything. If you don't sort of fully understand everything either. Once we start with the EMV acquiring section, and specifically when we move over to the EMV transaction section, as we move to the transaction steps, we'll start referencing some of these tags and parameters, that we've already discussed, and hopefully at that point, it will serve as a refresher, and it will serve to make understanding easier, because you'll actually see how the tag is being used during a transaction, either by the card or by the terminal. Okay. So once again, thank you very much for spending this time with me. I look forward to catching you guys in my next video, which will be video 11, and we should be starting with EMV cryptography in that section. Okay, thank you. Bye bye.